Today we start magnetic effects of current. This topic is relatively easy, but only one serious glitch is there. It is three-dimensional. It's very tough to explain three-dimensional things in two-dimensional plane. The two online is little tough. You need to work on the three-dimensional concept. That's it. Remaining parts are easy relatively. Okay. Magnetic effects of current. Make a note of it. So first and foremost thing is that Oyster experiment is there. Actually, scientists are there, na? They used to feel the science or physics is segment by segment. There is a segment called as magnetism. Okay. And one more segment called as electricity. Okay. Of course, if you want, you can take one more segment, thermodynamics. And if you want, you can take mechanics also. There are many segments. They had a good classification there. And they feel they're completely independent. Okay. So Oersted accidentally observed that whenever there is a current carrying wire, if you keep a magnetic needle close to it, it is getting deflected. That he observed it. Once he observed, immediately he posted in the journals, because scientific journals will be there, na? Science research will be published in journals. So scientific journal he published. Then everyone got surprised, because for them, current belongs to electricity, magnetic needle and deflection belongs to magnetism. Two completely different things are getting connected. Surprising. Something like current electricity or electricity is connected to gravity. You think about it. Electricity is connected with gravity. How it looks, right? You don't find serious relation between them, right? But electricity depends on like that, if at all. How surprising it is. Same way they felt surprised, and they start doing experiments, and they developed the segment, of course, electromagnetism. Later they understood that this is not two different things, it's single one only. Okay, but we'll discuss that later. And of course, that development made scientists go mad. Then start thinking you can merge anything, any two segments. They want to merge gravity, they want to merge electrostatics, weak force, strong nuclear force, everything they want to bring it to single segment. That's called as grand unification theory. Right? Scientists thought that we can make it in 1960s. 1960s and 1970s. The scientists of 1940s thought like we will get grand unification theory in 60s or 70s. Okay. Now 2023, not that we have. Okay, let us continue. Magnetic effects of current, Oersted observed. After Oersted observation, then comes the many scientists are involved in it. Ampere is involved in it, many are there. But the scientist who gave the explanation for this magnetic field, how strong it is, Oersted just said that there is a magnetic field, that's it. The mathematical value that it was given by Biot and Savatle. Biot, Savatle. Right. I think most of you know Biot-Savart. Biot-Savart says that, see, in the world, there is no such thing like only one kind of wire exists. Okay. Only one kind of wire. That means only infinite long wire. No, we can have a circular loop also. No? Need not be circular loop. It can be any arbitrary shape. Now, try to understand. Biot-Savart observed that shape will decide the magnetic field. Okay, the shape. It can be any arbitrary shape like this or like this. So how to deal with it? Then they got a small concept called as current element. Current element. Current element is IDL. For any wire you take it. You take a small piece. This small piece, assume it is carrying current I like this, assume. Okay, current is like this. Then current element will be a vector which is tangent to the small element at that point. Direction is the direction of current. This is ideal. Clear? Ideal. It's a vector quantity. So this is called as current element. I can't give you entire wire, but I can give it for current element. The small magnetic field generated by current element dB is equal to mu naught by 4 pi into IDL cross R cap by R square, or you can write R bar by R cube also. Doesn't matter. Both are same. So Biot-Savart says that this is the small magnetic field due to small current element. Small magnetic field is equal to small current element, magnetic field to small current element. If you want entire wire, simply integrate. Okay, sir, what's the problem? You told. The problem is 3-dimension. Now concentrate. Let us not make it complex. Let us make a easy one. Forget about this. Yeah. Simple, straight wire. I take a very, very small current element. There's a small piece of the small piece. And the current element is like this, right? Okay, let us make it. The current element is ideal. Okay. Now, what they say is that if at all you want to find magnetic field at this point P, first thing you need to know is that the distance between these two, obviously. And we represent position vector of P from the current element with R, right? Not the other way around. Okay, R. Now concentrate. The magnetic field at P depends on 3 factors. First one is the current element itself. Second one is the distance. Third one, anyone can say? Third one, angle between them, because sin theta will come na, cross product means sin theta. Theta 0 means sin 0, 0. Theta 90 means maximum. So it depends on one more factor called as that angle theta. It depends on angle theta also. 3 different factors it depends on. And last thing is that that's fine. We can the direction. IDL cross R. I think you know very well. A cross B will be along A or B, perpendicular to both. Now, IDL is in a plane, R is in the plane, IDL cross R must be perpendicular to the plane. Now, how to deal with it? Right hand thumb rule. Curl your right hand fingers from first vector to second vector. First vector is ideal. First vector to second vector, and thumb will give direction of magnetic field. If you can use your right hand thumb, curl your fingers like this, thumb will be into the board. So here magnetic field B bar must be into the plane. I think you know this notation, right? Do you know this? Into, out. I'll explain once again. Yes or no?
Yes, sir.
Okay. So there are two, there is a notation like this, into or into the plane or out of the plane. So this indicates which one? This one indicates into the plane, because in right now in this case it is into the plane, is outer plane. Outer plane is indicated by dot. Okay. Into, this is out of the plane. Clear? That's what you need to know. We have to indicate, observe, this is 3-dimension. The only problem is 3-dimension, nothing else. Otherwise, this is very, very easy. Sir, I can handle 3-dimension. Then problem solved. Okay. Right. This is Biot-Savart law. And now what happens is that let us come down to IDJE, NEET and mains. I don't think they'll ask you to derive anything by using Biot-Savart law, except advanced. Possibility is low, but maybe they may ask. Okay. Then if you think about mains now, sir, if they don't ask Biot-Savart law, what they do? They take standard shapes and they'll ask you. They take standard shapes and they'll ask you. Okay. So one of the first and foremost thing that you need to learn, and I'll tell you one thing, there are students who don't know Biot-Savart law. If you ask them, they'll get confused. dB is equal to mu naught by 2 pi ideal or something sin theta, blah, 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 they say. I know students, but they mug up these things and they get success. Because I personally saw that, hardly they use in NEET. NEET law, I think not even one question is there based on one. I think one is there. Mains hardly there is a question. I haven't seen, I don't remember, because every year mains will be too many papers. Tough to remember. Okay. So I haven't seen in mains. NEET law only one. Advanced, yeah, there are questions. Okay. There are few questions. Very rarely, I think, 40 years, 42 years, if you take it. Hardly 3 questions or something. So leave it. Let us continue. That is, now we go for B due to magnetic field due to infinite long wire. Sir, is it practically possible? Can I take it? Now, if you take an infinite long wire carrying current I, the current will be like this. But I'll tell you one thing. To indicate it is infinitely long, it must be written like this. Dot line indicates it goes on. Now, if at all you take if you take a point P here, now you need to take the perpendicular distance, right? This is the one. You know the definition of perpendicular distance, like 90 degrees it is. Okay, this is R. Now you have to calculate magnetic field here. Yeah, you can use this one and integrate. Wait, infinite long wire. Don't you think infinite field? My answer is not much of discussion. No, it is not infinite field. Take it for granted. So magnetic field B. Tell me, anyone knows that magnetic field B is equal to mu naught I by 2 pi R. This is the first thing. In crash course and all, what we say is that don't remember Bayot-Savatla, drop it. Remember this. Infinite long wire. Okay. Now, how to get the magnetic field? Right hand thumb rule. Right? Simply keep your right hand in the direction of current. Right hand thumb. Like this. And curl your fingers. If you keep your fingers here, it will be in. It will be out here. So, magnetic field will be outwards here. Magnetic field will be inwards here. Magnetic field will be in on this side, out on the side. Actually speaking, magnetic field is a closed loop like a circle. Magnetic field is a closed loop like a circle. Observe. And we can say like this. Now, this is the case. Magnetic field, I use green color. It's like a curve. Can you understand that? There's a ring. You have to understand three-dimensional ring around it. Okay. If I see the top view, magnetic field will be circle like this. And because I'm looking from the top, I can see current like this. Current will be in this way. Like this. Current will be like this, out. Current will be I. Magnetic field will be B. B bar. Right. Of course, I made only one line. There are plenty. Many lines will be there. And as you come closer and closer, they're crowded actually. They are crowded when you come closer. And when you go far, they are less crowded like this. Reason is very simple. As you come closer, magnetic field strength will increase. Let us not confuse ourselves by taking too many lines. We take the required line. That means the line which is passing through P. That's it. This is a magnetic field due to infinite long wire. You need to remember this, and we have to solve problems based on this. Okay, right. So next one, B due to circular loop. In this also, I won't do derivation. You can derive everything. Circular loop. What is that? Suppose you have a current carrying loop which is in a circle form like this. Current is going I like this. Then magnetic field will be magnetic field at the center will be, observe, B is equal to mu naught I by 2R, where R is the radius. Where R is the radius. Sir, I have a doubt. How do you decide? How do you decide? Current magnetic field B is outside here. Magnetic field B bar is outside. I'm using green color for magnetic field. Remember that. How can you decide magnetic field is outside? Now, very simple. I explained it to you that I don't know how to make right hand thumb rule. Does it look like thumb? But remaining fingers are a little tough to make, right? My God. Somewhat like finger. Paper madri irukku. It's okay, leave it. Let us continue. You curl your finger, keep thumb like this, and fingers will give you magnetic field. And one point I'll tell you, they can be swapped. That means when thumb indicates current, fingers indicates magnetic field. If fingers indicate current, thumb indicate magnetic field. So curl your right hand fingers like this. Curl your right hand fingers. Then thumb will be outward. So this is our case. That's it. These are the two things you need to first. Then B due to finite length. Wire. Sir, infinite length wire is fine. Finite length wire, how do you take it? I'll tell you that. Finite length wire, there's a small problem because how do you decide that the finite length concept? That's a problem. Just a minute. Yeah. Assume assume there is a finite length wire which is carrying current I. Okay. And I want magnetic field at distance R. At this point, I want. How to deal with it? Now, length, how can I bring it? What they do is that they join the topmost point of the wire to the point where we need to find magnetic field. Sorry. Like this. Check it. They join lowermost point also. They take upper part as θ1, the lower part as θ2. They take. And of course, current will be there. Now you can calculate magnetic field. So magnetic field B due to finite long wire is that mu naught I by 4 pi R sin θ1 plus sin θ2. This is the formula. Sir, I have a doubt. Can I get this result from this? Definitely yes. Can you feel it? If I start stretching it up to infinity like this, θ1 will increase or decrease? Tell me. θ1 will increase or decrease? Will increase, right? Will increase. If you keep on pushing up to infinity, θ1 go to 90. θ2 also 90. So infinite long wire means put θ1, θ2, 90. Sin 90 is 1, sin 90 is 1. 1 plus 1 is 2. 2 by 4 is 1 by 2. So exactly same answer you will get. But my strong recommendation is that remember these three. Remember these three formulas. You have to mug up. My strong recommendation. These three formulas are going to lead. Sir, I have a doubt. This is infinite long wire. No problem. Finite long wire. So that means part of infinite long wire. That means what is the meaning of finite long wire? You're saying part of infinite long wire. Okay, good. Now part of circular loop. Use unitary method on or over angle theta. Use unitary method over angle theta. Sir, what? Suppose instead of having complete ring, okay, you have some part of the ring. Some part is there. What to do? What is the meaning of unitary method? Very simple. Complete 360 degrees. This one is there. Maybe this is 120, assume. 120 will have how much? 120 by 360 into that value. 1 by 3, 1/3 of the value over. You can use unitary method here. Okay? You understand? So if you want, I can make a diagram there. You can use unitary method over there. That's it. You can use unitary method, nothing else. Now we have to go through some problems. I'll give you worksheet. Lot of problems are there. It depends how much you can do. It's a matter of practice. And remember, this segment you should not practice once again before exam. That means some topics need to insist really seriously. Some topics you should not put that much of time and effort. The topics that you need to learn while teaching itself is magnetism. So I'll send you the worksheet. You have to learn it. You'll get practice also here. 1 minute. Sir, first question is, I think, straightforward form substitution. Why you give? To give one information. Question number 1 is that an infinite long wire carrying current 10 ampere, I is equal to 10 ampere. Okay. Find the magnetic field due to this wire at a distance of 20 centimeter. So R is equal to 0.2 meter. Directly I'll write. Calculate magnetic field. Sir, direct formula, na? Yes, but one information I would like to give. Mu naught by 4 pi is equal to 10 power minus 7 SI units. Right. Okay. Right. So this one you need to remember. To give this information only, this question is being given, otherwise not there in it. So magnetic field with infinite long wire will be mu naught by 4 pi is 10 power minus 7. Mu naught by 2 pi is there. Multiply numerator and denominator 2. You will get 2 mu naught I by what? 4 pi r you get. 2 mu naught by 4 pi r you will get. So anyway, mu naught by 4 pi is 10 power minus 7. 10 power minus 7 into 2 into I. I is equal to how much? 10 ampere by R. R is equal to 0.2. How many times? 0.2, 10 times. The answer is 10 power minus 5 Tesla. Unit of magnetic field. SI unit of magnetic field is Tesla. That's it. Okay. Question number 2, no need to discuss. Answer is 10 power minus 8 Tesla. Okay. Right. So question number 3. Easy to deal with. Right. What is the key point here? Above and below. I don't want magnitude. If you can give direction enough, above and below. The basic purpose of this question is direction. Keep your thumb there, then you'll understand that magnetic field. 1 minute. Magnetic field above and below. Below will be into the paper. above will be out of the paper. That's what I'm expecting. Magnetic field B. The value, it's not a problem. You know where the value is 2 into 10 power minus 6. I'm not focusing on it. 2 into 10 power minus 6 Tesla. Standard stuff. Substitute the data, you'll get the answer. Clear. That's it. So, fourth one is also easy. Fifth one also easy. Fourth one, homework, you do it. Fourth one is 6 into 10 power minus 8 meters actually. Because I want very strong amount of 10 Tesla magnetic field is required with only 3 amperes. Distance must be very small, and the distance is 10 power minus 6 meters. Fourth one. So means what? I would like to inform you in question number 4 that magnetic field will be very feeble. You will get. Generally, magnetic field will be feeble. Anyway, 0.1 ampere. Fifth one. Okay. Now, sixth one is what? Simple proportionality. Anyone can give answer for sixth one? Carry on. Answer is 4B, question number 6. This ratio of proportions, actually, I won't discuss, but one question will do it. And next one also will do it, seventh one. An infinite long straight wire carrying current I produces magnetic field B at a distance D from the center. So magnetic field B is equal to mu naught I by 2 pi D. Because, I also capital I, no? Let us take same capital I. Okay, right. If the current is doubled and distance is halved, so what to do? I practice like this. I'll make a circle around the constants. Then I'll take the ratio. B1 by B2 is equal to I1 by I2 into D2 by D1, because D is in denominator. That implies initial magnetic field is B, final magnetic field B2 I need to find is equal to, okay, if current is doubled, so I1 is I, I2 is 2I. If current is doubled and distance is halved, so initial distance is D, final distance is D by 2. Now D gets cancelled, I gets cancelled. Then you will end up at what? Tell me, 1 by 4. So finally, you can write like this. B2 is equal to 4B. The magnetic field becomes 4 times. That's it. Anyway, seventh one, I want answer. Seventh one, I want. Right. Now observe question number 7 and 8 can be done by what? A shortcut method. The shortcut method is that I told you already that first of all, you take the formula B is equal to mu naught I by 2 pi R, you take it. Now make a standard stuff, circle around the constants. Then write down delta B by B is equal to delta I by I plus delta R by R, and multiply with the power. What is the power of R? -1. So it will be minus will come like this. And if you multiply throughout the equation, you will get what? Percentage changes. So assume that I multiplied with delta 100, delta B by B into 100. This is the percentage change in magnetic field, must be equal to delta I by I, percentage change in current. Okay. Current is decreased by 2%. So decrement will be given by -2, minus, and point P is brought 1% closer. 1% closer means +1, because delta R by R into 100 is +1. Right? So what is the answer? Tell me. Decreased. Good. And brought 1% closer. Closer means decrease in length. Na? So it will be plus. Sir, purila. Observe carefully. This minus sign is because R is in denominator. Right? And delta R by R into 100 must be equal to -1. Why -1? The point is brought closer to the wire. That means R decreases. So you have to use one more -1. So the total value is percentage change in B. In B is equal to -1%, or else I can say 1% decrement over this small percentage changes. You need to handle it. Okay. So question number 8. Answer. Anyway, I'll explain. I'll give it to you directly. 3% increment. Question number 9. 1% decrement. Yeah. Question number 10 solve. Quick. Correct. Arun. Okay. Record. Now it is carrying, the wire is carrying current like this, and this one is carrying current like this. Both are carrying in same direction. This is 1 ampere assume. This is 3 ampere. Doesn't matter. Whatever you want, you can take. Now magnetic field due to 1 ampere will be B1 is equal to mu naught I by 2 pi r. Of course, this is not mu B1, B. So let us calculate B1. B1 is equal to 2 into 10 power minus 7. I is 1 ampere. Distance is 10 centimeter, right? Because midpoint, now it is 10 centimeters. So 10 power minus by 10 power 10 into 10 power minus 2, 10 power minus 1. So that is equal to 2 into 10 power minus 6. 2 into 10 power minus 6 Tesla. Right? This is the magnetic field that, okay. Then what about B2? B2 is equal to 2 into 10 power minus 7, that is mu naught by 2 pi, into 3 by same distance, 10 power minus 1, is equal to 6 into 10 power minus 6 Tesla. These two are fine. These two are fine. But only problem is that only problem is direction, right? How to get it? Because of this infinite long wire, magnetic field will be inwards. This infinite long wire outwards. Now they are in opposite direction, so we have to subtract. So net magnetic field B is equal to 4 into 10 power minus 6 Tesla. Assume that by chance the current is reversed like this. Oh, I reversed the thing, but not the arrow. Okay. If the current is reversed like this, then both will be added, and you will get what? 6 plus 2, 8 you will get. Anyway, there are many questions there. Ekkachakamana practice, that's what I told you. In case of magnetism, you should not come back to this one once again. In case of magnetism, you should not come back to this one once again. You have to do complete practice right now. Right now means that when you are learning, you have to do complete practice. Don't leave anything for revision. So there are a lot of questions. As much as possible, go through it. There is no, I won't tell you which one to solve, which one not to. Randomly, you keep on question number 11, 12. Right? 11 is about finding magnetic field. 12 is about finding distance R. 13 is about current. So these three questions you have to solve. Lot are there. I strongly recommend that solve it. See that in case of option B, I'm going to directly solve B. They want at the midpoint, right? Check it. They want magnetic field at the midpoint P. Okay, this is A. This is also A. This is carrying current I. This is also I. So you know that magnetic field due to this will be mu naught I by 2 pi R, 2 pi A. Because of this also same. Now concentrate. Because of this, magnetic field will be inwards. Because of this, magnetic field will be outwards, out. So it gets cancelled. So B net is equal to 0 there. But what I do is I'll copy this. I'll go for the next one. I'll write like this. This is B. This is C. Only difference between B and C is the current, right? The current is 2I. The current is 2I. Now, the first one, B1, I'll take this as 1, that is 2, right? So, B1 is equal to mu naught I by 2 pi A, and magnetic field is inwards. And B2 is equal to mu naught 2I by 2 pi A outwards. So outwards, inwards, definitely outwards is stronger, so it will win. So net magnetic field will be, you have to subtract them. It is mu naught I by 2 pi A outwards. That's it. That's it. So you can solve many, but I think that there is a serious trouble when it comes to H. Serious trouble is a small. How to solve H? First point is that when you have like this, you divide into two parts. One is this one, other one is this one. Now, magnetic field due to this is 0. Sir, why magnetic field due to this is 0? What I do is that I'll copy only that part. What is the most important thing is that all these formulas are derived and they are shortcuts. Core formula is this one only. Okay. Just I'm telling you to so that you can understand, or else simply remember, that's it. The point is, if I take ideal direction is like this. Check it. Ideal is like this, right? Current element. And R is also there. That means what is R? Distance between current element to the point. But angle between them is 0. Check it. Sine 0. The magnetic field will be dB is equal to mu naught by 4 pi into ideal cross R cap by R square. This cross product will be 0. this cross product will be 0. Understood? Because they're in same direction. So any element you take it, everything will be same. So magnetic field will be 0. Then why this much explanation is required? Student will say like this, sir, it is on the wire, right? What they say is perpendicular distance, no sir. Perpendicular distance is 0, right? How? Sir, I'll extend the wire like this, and point is on the wire. So when point is on the wire, perpendicular distance is 0. That logic is good. I appreciate, because see, if I ask you, there is a line like this and the point is there. What is the perpendicular distance? First thing, you can't line segment. For this line segment, you can't write perpendicular. What we do, we extend and then take the perpendicular. That's also good. But in the process of extension, you get the perpendicular distance 0 there. So what they do immediately, they go for infinite long wire formula. B is equal to mu naught I by 2 pi r. R is equal to 0. Answer is infinity. Infinite magnetic field. Tappu. So final conclusion is, if the point is on the wire, magnetic field is 0. So what is the conclusion? B is equal to mu naught I by 2 pi r is valid only when r is not equal to 0. If r is equal to 0, magnetic field is 0. This is the complete explanation. Right? This is the thing you need to remember. Okay. So now this part won't generate anything. What about this one? This one gives you one more field. Right? My point is that infinite long wire will generate B is equal to mu naught I by 2 pi a, infinite wire, because it is half infinity into 1 by 2. Sorry, infinity by 2 is infinity, na? See, you are dividing magnetic field, not the length. In that way, if I take infinite long wire, should create infinite magnetic field. So when you accepted that infinite long wire creates finite magnetic field, then you have to accept this also. Sir, how can I accept that? That's a good question. But anyway, it will be a little bit out of discussion today. So if you're interested, we'll discuss after the class. How come? How come infinite long wire can create finite magnetic field? So this is the case. Sir, I don't accept this. Then I have my own weapon, you know. I'll bring this one. I'll bring this one. What is this? Observe. Observe. Magnetic field B is equal to mu naught I by 4 pi r into, I will take the only required part. This part I take. Now I need to, for this one, I need to apply, right or wrong? So what to do to get this one? Join the topmost point and join the bottommost point. Wait. As it is going to infinity, this keeps on increasing, right? What is this angle if I go to infinity? What is this angle? Anyone can tell? 90 degrees. Theta 1 is 90 degrees. So sine 90 plus sine theta 2. Sine theta 2 means what? See, if the wire is having some length below, then what you do is that you join these two, right? Like this. But as you're bringing it lower and lower, this theta keeps on decreasing, right? This theta keeps on decreasing. So this one, now theta becomes 0. Check it. So what the value? Mu naught I by 4 pi r. Instead of r, I have to put a here into, let us write a. Sine 90 is 1 plus 0. So magnetic field B is equal to mu naught I by 4 pi a over. Simply remember, half infinite wire, half magnetic field over. That's it. That's the best option. Now, after that, same standard, my right hand thumb rule, everything you can solve. Key, what I'll do is that I'll send the snapshot in the group, key for all three. Okay. And I won't give any heading over there. Simply three will be there. They're in order. That means first one is for question number 11. Second one is for 12. And third one is for 13. This is for first. I sent it to you in the group. Check it. I'll write the question number 12. That's better. 12 and 13 I can give together. I am giving 12 and 13 together. Done. Yeah. Okay. Right. Try to solve as much as possible. I repeat, the practice must be done now. We don't have enough time after that. Okay. Now question number 14 onwards, it's circular loop. Okay. I'll solve some questions. Question number 14.
So,
Yeah, tell me.
without
Yeah, tell me.
so,
Question number 14. A circular loop of radius r is equal to 20 centimeter. So 0.2 meter directly, right? And carrying current I is equal to 2 ampere. Very good. 2 ampere. Find the magnetic field center of the loop. So B is equal to mu naught I by 2R. Actually, we know mu naught I by 4 pi is equal to 10 power minus 7. When we need to deal with mu naught by 2 pi, what we did, we wrote 2 into 10 power minus 7. Now, when you need mu naught by 2, because here mu naught by 2 is there, na? Then what we do, 2 pi into 10 power minus 7. So don't try to simplify. Simply use 2 pi and just leave it. So that is equal to 2 pi into 10 power minus 7 into current is 2 ampere. Distance is 0.2 meters. So it will be 10 times, right? So answer is magnetic field B is equal to 2 pi into 10 power minus 6 Tesla. You stop it here. If you want, you can go deep. That's it. Right. Question number 15 key. I'll give you the key. 15, 16, 17. I'll give you the key. Okay. I'll give you the key, and the entire 18 also I'll give you the key. Go ahead. So I recommend like this. Don't solve up to anything up to 17. 18th one, randomly you take it. I recommend once you start going for F onwards, toughness will increase. So pick randomly and try to solve. Go for 18. I'll send you the key, don't worry. Right. 12th one. 12th one, observe. B, I'm going to solve. That is, this is carrying current 2I. And the other one is carrying current I, right? 2I and I. Directions are exactly given. Perfect, right? If the magnetic field at P is 0, this is point P. If magnetic field at this point P is 0, calculate the value of R. Right. Concentrate here. At this point, magnetic field will be in. Because of infinite long wire, this will be in. This infinite long wire, it is out. Both are opposite. That's the first criteria. If that is complete, then only you can go. Otherwise, time waste. So magnetic field to first wire will be mu naught I, IL, 2I, mu naught I by two pi A plus R. That is the magnetic field due to the first wire. That must be equal to, why equal to? Because they're opposite. They must be equal to produce net zero. Mu naught I by 2 pi R. Then mu naught by 2 pi, mu naught by 2 pi gets cancelled. I gets cancelled. Cross multiplication will give you 2R is equal to A plus R. That implies R is equal to A. What is the answer given? Yeah, that's it.